Okay, good afternoon or good evening, everyone. This is 3.3 and 3.4. 3.3 is going to be basically the bulk of today's lesson recording. 3.4, you should already know the skills needed. I'm going to give you already all the skills that needed in order to solve 3.4. I have done very few, what was it? Word problems, and that's because I just want you to get the basics of just the math, okay? So let me get started on this. All right, so if I ask you to solve some kind of equation like this, okay? First of all, before we begin, I would like to say that you need to know the quadratic formula, okay? So what you always want to attempt doing is factoring the equation. You want to set it equal to 0, factor the equation, set it equal to 0. If you cannot factor, that's when the quadratic equation comes in. That will give you the solutions of a quadratic formula, basically the x-intercepts, in order for you to find the solution. So basically, if a quadratic function is prime, it means you cannot factor. Therefore, you use a quadratic formula. This formula is on one of the sheets that you are allowed to use on your exam. So let's start with 2x squared plus 4x minus 16. The first thing I noticed is to start dividing everything through by 2. Okay. Now the right side is 0, so that's easy. So then the 2 will disappear. And you attempt to factor. If it factors, great. If it doesn't, you gotta use quadratic. But in this case, it does factor. Okay, I need the factors of -8. That gives me 2, so that's -2 plus 4. I then set each of these equal to 0. This has to be 0. So if they give you an equation in which the right side is not 0, you got to move it to the left to get a 0 there. You equal them both to 0, you get your answers, x equals 2 and x equals -4. What does that mean? Supporting it graphically means if you were to graph this equation under y1 and this equation under y2, you're basically telling me where they meet. 0 is a function. 0 is a viable equation. So if you were to plug this in into y1 and you plug this in into y2, which is just a 0, which is the x-axis, y equals 0 is the x-axis, you're trying to see where they meet. Whenever you have two things, two equations equal to each other, graphically, it means where they meet. Okay? All right, here's another one, x squared minus 6x minus 9. This is one that we just had on the previous recording. It's x minus 3, x minus 3. You set them equal to both. So when you support it graphically, you should only have one intercept. And that is what you have down here where it asks you, what do you notice about the number of solutions in the x-intercept? I already gave that on 3.1. It means there's one intercept because there's one solution. X equals 3 and x equals 3 is the same solution. Okay. The square root property is down here. And that's sort of another way to solve it. Why the square root property? Because this right here, if you end up with x minus 3 times x minus 3, let's see if I have more space over here. Nope, I don't. X minus 3 times x minus 3 essentially means x minus 3 squared. Okay. So x minus 3 squared, let me grab this right here. Right here. X minus 3 times x minus 3 equals 0 means x minus 3 quantity squared, because it's the same thing twice. So then you would take the square root of both sides. You would get x minus 3 equals plus or minus. Don't forget, you always plus or minus. X minus 3, but because square root of 0 is just 0 and it's not positive nor negative, it's just 0. And so you get 3 as an answer, only one solution, which is the same thing we got here. We've got the same solution twice. All right, so know the square root property. When you take the square root of both sides, you do have to put a plus minus of that number. That's all that it is saying. Plus minus of that number. If it's a 0, that plus minus does not exist because it is no plus minus. Okay. Oops. Oh, no. Oh my gosh, I dropped my water. Oh, my laptop. So sorry. trying to do too many things here, too many things. Okay. All right. I did another typo. I'm sorry. Let me just. My typos. I won't have as many typos. I promise. All right, so let's just go over some of these problems. Okay, if I have x squared equals 100 and I want to solve for x, I take the square root of both sides and I end up with plus or minus 100, which is plus or minus 10. So it means that you just don't have 10 as an answer. It's a positive 10 and a negative 10. You have two answers. Over here, we want to start by dividing by 2. You get a negative 5 in this case. So you get the x, you get the square and the square root to disappear. However, on this side, you do end up with an I because that negative has to come out as an I, and you end up with the plus minus. This 5 does not reduce, so that's it. That's your answer. Okay. If you have this kind of situation where you have a binomial squared, it doesn't matter. If there's a number outside, get rid of it, move it to the other side. You end up with x minus 1 squared equals square root of 7 when you are trying to get rid of the square. But don't forget to attach your plus minus here. Then you move the 1. That 1 does not add to 7. That 1 is outside. So that's why the answer is 1 plus or minus square root of 7. So make sure you note the differences completely. Okay. All right. The quadratic formula is pretty easy because a quadratic formula is just putting your problem in standard form, standard form, standard form, standard form. I can't stress that enough. You do not extract your a, b, and c if it is not in standard form. It has to be ax squared plus bx plus c equals 0. If it's not the case, you cannot and should not start the problem because this will not work out. Okay, so for the next two problems, it's going to say use a quadratic formula to solve. This one's set. This one's ready to go. A, B, C. This one is not. This one needs to be distributed and things need to be moved so that it's equal to 0. Okay, so we're going to go ahead and do that. Okay, so for this problem over here, and don't worry about the numbering, okay? So for this problem over here, I needed to distribute the x, do work on magic, set it equal to 0, then extract ABC. Once I extract ABC, then I do the quadratic formula. So it's the opposite of B, plus or minus the square root of B squared minus 4AC. You do the math, you try to reduce inside the radical as much as possible. I actually end up with a perfect square inside, which gives me a 2, and then I have to separate it. So your answer, when you're doing this on a test or on the homework, your answer will not be that because these are all whole numbers, and you can definitely take the answers and add and subtract them appropriately. So you would do one equation with the plus, so 4 plus 2 over 2, that's this one. And then you cover up the plus and you do the one with the minus. 4 minus 2 over 2 equals 1. So these two would be the two answers. How can you check? Well, you could graph this side. Let's see if I have my pencil. You would check this actually on the calculator. You can't put variables in the calculator when you're on the big screen here. You can't do them here. But if I go to y equals, I can use my graphical approach. So what you would do is you would plug this into y1. You would do this equation into y2, and they should meet at two different places. This is a happy face or a parabola. This is a line. And so they should cross at two places. Your x values are going to be 3 and 1. That's what they're going to meet. Not 3, 1, not 1, 3, 3 and 1. There are two solutions to this problem. Okay. All right. The next one is set. That one is ready for you to put A, B, C. You plug them in. You do work your magic. Turns out that in here you have a negative. You take that out as an I, and this is your final answer. Okay. So unfortunately, on the second one, it's not possible to actually graph this in the calculator and find the solutions, because the solutions on the calculator are only given to you if they are real answers, even on the graph, especially on the graph. Okay. There's no going around it. There is no going around that one. So this one, you just have to trust yourself. All right, let's do a few more. Okay, so the next thing is just talking about the discriminant. The discriminant is the part inside the quadratic radical here, okay? It's called the discriminant, and that tells you the number and type of solutions. If the number inside the radical gives you a less than 0, which is a negative, remember every time we got a negative, we ended up with a no real solution, which means two imaginary solutions. Why two? Because you've got a plus and a minus. It's got plus of that imaginary, minus of the imaginary. If the piece inside gives you a 0, then this will be completely, if you add 0 or subtract 0, that's the same thing. So you only really end up with one solution, which is negative b over 2a, and that is this. If you end up with a number bigger than 0, it means it's a positive, and you're going to end up with two real solutions. So you're going to see 2 points where the graph crosses the x-axis. Okay. So if I ask you, what's the discriminant, and tell how many types and solutions, there are 3 problems. I will go over that right now. This is very, very easy. You just have to know what they're asking. That's the only hard part, knowing what they're asking and what equation you're using. So if I ask you 2x plus x squared equals 4, what is the discriminant and how many types and number of solutions do you have? First of all, you have to make this a, the quadratic function needs to be set equal to 0, okay? So you do have to have it set to 0, just like in quadratic function. And then you extract your a, your b, and your c. So here we go. A is 1, b is 2, c is negative 4. Forgot to put that. Okay. Once you do that, you're just going to use the discriminant. The b squared minus 4ac. This is b, I squared minus 4ac. You do the math, you get 20. Once you get that number, you then compare to one of these. It will only fit one of these. That number is either going to be less than 0, equal to 0, or greater than 0. Turns out 20 is bigger than 0. Therefore, we're going to have 2 real solutions. This is the number of solutions, 2. And this is the type of solutions, real solutions. And that is all here. You can write this in your note card. This is allowed. What is not allowed is for you to write this example. Okay. Let's try the next one. This is almost set up. I do have to move the 5 to the left. So I have it equal to 0. I have a equals 1, b equals negative 2, c equals 5. I then plug that in, b squared minus 4ac. And I check that the number that I get is less than 0, which means negative. So if I had a negative under the square root, that would make it 2 imaginaries. Okay, 2 imaginary solutions. Okay, Last one, if I have AB, I do B squared minus 4AC. I end up with exactly zero, which means one real solution. One real solution. Okay, and that is that. That is quadratic, factoring, and discriminant. Now we're going to go into the solving of the inequality. I'm going to do the inequalities different. I am not going to have you do the whole line in plus and minus, but still watch the video so that you can see the difference and then put everything together. I'm going to do 2 applications and we'll be done. All right. Okay. When you are solving an inequality, okay, again, you can have the plus minus situation all the way through, but more importantly, you have to understand what this means. You want to support this graphically. This left side is an equation, y1, and the right side is a second equation, which is basically, in this case, the x-axis. Your job is to figure out where this graph is below the x-axis, okay? So the first thing you're going to do is you're going to factor this out and find the solutions as if this were an equal sign. So I get a solution of 4 and -3. Now the book will tell you to put a 4 and a -3 on a number line and then plug in numbers that are before, in the middle, and after those 2 pieces. You'll see it on there. I don't want to go over it. But what I want you to do is just to graph this and then just give me a general idea with the exact answer at the end. So the question is this going to be a happy face or a sad face? It's going to be a happy face because my A value is 1. Remember that? We've done this before. So it's going to be a happy face in which the the 4 and the -3 are going to be the x-intercepts. Okay, so I am going to do a really quick sketch. I'm not even going to be perfect about it. You can sit there and put that in the calculator and be perfect about it, but it's not needed. So it's going to be a happy face with a -3 and a 4 as an x-intercept. The question is, where is this graph less than, so check out the colors, less than, where is the graph, where is the parabola, less than 0? Less than 0, here is my x-axis, less than 0 is the bottom portion. So it's between -3 and 4, between -3 and 4. Okay, now, it does go through -3 and 4, but you have an inequality that does not have a line underneath. So your answer should be, well, this is not correct. There should be parentheses there. Had my whiteout. So these should be parentheses because this does not have an equal sign. Doesn't matter if it goes through the graph. It depends on, it always depends on what they gave you as the equation. Okay. We're going to do one more. We're going to do the one that instead of asking for the bottom, they're asking for the top. No matter what, you still have to set it equal to 0. So basically move everything to one side. I grab these 2 to the left. And now I'm looking for the places in which the graph is greater than or equal to 0. So it means above the x-axis, above the x-axis. So before I do anything, I do need to factor. So I end up factoring. Please be really good in factoring. You need to know how to factor from here until the end of this class. I ended up with 2x minus 3, x plus 4, this. If you couldn't factor, you'd use quadratic formula, but we're not going to have any of those. 3/2 is the same thing as 1.5. So it means it's going to be also a happy face because it's positive. It's going to be a happy face with x-intercepts at 1.5 and -4. And you graph that, you make a quick sketch. I don't even know how low it goes. That's not the point. Okay, it looks kind of crappy, to be honest. But they're asking me, where is this graph above the 0? So where is it above? And these 2 little lines that are coming up. Not this part, but these 2. So how would you state that in interval notation? You would say it's coming from negative infinity, because you always read them left to right, from negative infinity all the way to -4, and there's a gap, so you would put a U, and it picks it back up on 1.5 all the way to infinity. And that's why the answer is this. Now this one has an equal sign at the bottom. Notice that? And that's why these are brackets. Okay, because they have an equal sign at the bottom. So that ends 3-3 with these inequalities. Do it this way. This is all we need. Okay, you can also just go through and figure out the algebra behind it to just have it, you know, sink in and just blend with what is going on. The last part is going over some applications. Okay, one of the questions is, I don't know if I have it up there, but they basically tell you that you've got two numbers whose total sum is 45. So they gave you this part. You have no idea what the numbers are. So you make a variable. You always state your variables. So one number, you can make it X. The other number has to be 45 minus X. If I did not have this at all, and I'm given the total and I'm given one of the numbers, then you take this one away from this to give you the second number. Okay. If I were to ask you what are the restrictions on this number, well, that number cannot be 0. Okay, because then you wouldn't have two numbers, right? And it cannot be 45, because if it were exactly 45, that would make this 0, and that would just give you one number, which is also not true. So the restrictions are, the numbers are going to be between 0 and 45, not including 0, not including 45. The question is, what are the numbers? Well, we know that the area of these two numbers, if I wanted to multiply them, that would be the area. Okay, and this would basically give a sad parabola. Okay, that would give a sad parabola. Now my sad parabola is your x coordinate. Your x coordinate is the one number. The y coordinate, p of x, that gives you your multiplication of these numbers. Okay. So if you multiply these two numbers, okay, that would create your y variable. So you're going to have a sad face, whatever dot that is, that's going to be the number, one of the numbers, and then their product. Let's suppose you want to maximize the product, but you don't know either number. This is how you do this. Okay, that's the equation for the maximize just the equation of multiplying those two numbers. Let's say that I want to know, I want to set this equal to 504. So the product is going to be equal to 504. So I would set it equal to 504. I would use the quadratic formula to figure out what the number is or what the numbers are. And it turns out that the numbers would be 21 and 24 if their product was equal to 504. That's what it would mean. If it's equal to a different number, if their product equals something else, then you would just change that number, do the math, and then get the two numbers. If I want to be able to find the maximum of that equation, okay, this one was just an example. I set it equal to, if the product is 504, what would that be? But their maximum, if I want to know what the maximum was, then I would want to find the vertex. And we already went over how to find the vertex, is negative b over 2a, and then plug that back into the equation and you get your y value. The next one I was going to do is a going to do with a parabolic motion of a ball. I believe it's going to be a golf ball. But now that I already did that in the previous one, you should be able to get that right. So practice these. Let me know if you have any questions. I'll definitely go over them in class. And if you can attend on Thursdays, that would be awesome. Okay. Thank you so much. And I will see you in the next recording.